We're doing it. Mr. Smith, that's me. Oh, I'm in a hot air balloon. Excellent. I'm up here. I'm represented by this point. Okay? I'm currently headed to you horizontally, so I'm moving this direction. Kaboom. And you happen to be down here looking up at me. Right there. Okay, it doesn't matter which way you draw the triangle. It's going to be the same thing. And my altitude is 400 feet, and I'm traveling horizontally. All right, so all that means is this side of the triangle back here is 400 feet, and it's not changing because I'm traveling horizontally.
How do we know it's a right triangle?
Okay? Because it's, well, what do you mean? You're straight down to the ground. It has to be horizontal or right triangle. I mean, you could draw a non-right triangle if you want, but 400 feet means perpendicular from the ground and 400 feet up. Not over a mountain. It's a completely flat meadow. Okay? That's exactly at sea level. Okay? All right. So as he moves, there's two sides of the triangle that are changing. The side on the ground and the side up here. Okay, the hypotenuse. Which one do we know the rate of change of?
X.
We know x is changing how fast?
At 3 feet per second. 35.
True. So dx dt, I'm thinking, is x getting larger or smaller?
Larger.
It's getting smaller. Yeah. So the rate of change is really negative 35 feet per second. The question's asking you, how fast is the distance between you changing? No, how fast is the angle of elevation changing? Never mind. What am I even reading here? How fast is the angle of elevation changing? So look, we know dx dt. We want to know d theta dt. So we need an equation that links x to theta. What's it going to be?
Sine.
Not sine. Sine would link theta to z.
Tangent.
Tangent works.
I thought we had
We don't. We know we have z, but we don't have dz dt. Okay. So you got to think, if you put z in your equation when you derive it, you're going to get a dz dt, and that's going to be kind of a pain in the butt. But if you put x in our equation, we can get a dx dt, and we know what that is. So we could do, and this we looked at this one just like this yesterday, really. We can say tangent theta is 400 over x, so we can derive it like this if we want. Or we can do cotangent and put x in the numerator and derive it that way, which is a little bit easier. Okay? So I wouldn't do tangent, although you can, it'll work. I would do cotangent of theta is x over 400. And we did almost the exact same problem yesterday. When you derive cotan, you get negative cosecant squared theta times the derivative of the inside, which is d theta dt. And that equals, when you derive x over 400, you get 1 over 400 dx dt. Cool. We want d theta dt. We know dx dt. The only thing we don't know right now is theta. All right? And we don't even really need theta. We need cosecant of theta. Cool? So remember, we said cosecant is the reciprocal of sine. Remember? So sine of theta is opposite over hypotenuse. So cosecant, which is what we really want, is the hypotenuse over the opposite side. So if we come up here, do we know what the hypotenuse happens to be? It is z. Do we know what it is right now? It's 500, so that's super easy. And the opposite side is 400. So what's cosecant of theta? 100. How about 500 over 400? Hypotenuse over 500 over 400, which is 300. Timeout. Why are you guys just saying hundreds? It's the hypotenuse divided by the opposite side. No, it's just 500 divided by 400.
5 over 4. You cross out the zeros.
I thought we were solving for x, and it's 300. Yeah.
Guys, we don't need x. We don't need x. Timeout. We are using this equation right here, and we want to find d theta dt. To find d theta dt, we need two other variables. We need dx dt, and we need the cosecant of theta. The cosecant of theta was 500 over 400 because of this triangle right here, which is really 5 over 4. So this is going to become negative 5/4 squared times d theta dt equals 1/400 times dx dt. And that was, we said already, negative 35. Okay? And we're just going to solve for d theta dt right now. Okay, so squaring this is going to give us 25/16, and it's negative. And over here, we're just going to have negative 35/400. We can reduce all these if you want. But really, we're going to multiply both sides by, I'm just going to cancel some things out here. We're going to multiply both sides by 16, negative 16 over 25. Okay? And we got to simplify this down to get our final answer. So it turns out that, maybe you know this, 16 goes into 80. 16 goes into 400. Anybody know this? How many times? 25 times. 16 goes into 425 times, which means this is crossing out to a 1, and this is crossing out to a 25. Then we can also cancel out a 5. So 35 is canceling to a 7, 25 to a 5, which means we really have negative 7 times negative 1 over 5 times 25. What are the units on there? This is radians, and the unit time we were using was seconds.